Hello, this is Santosh Shinde, Assistant Professor IT Department, VPKB IIT Baramati. Now today the agenda is clipping, which is second chapter in the fifth unit of computer graphics. First chapter we had talked about segmentation. Now this is the second chapter which talks about clipping. So this is the agenda of this chapter: introduction to the concept of clipping, what is point clipping, endpoint codes, which are also called as region codes, which we use for clipping lines. And in this context, we have the line clipping algorithm by Cohen-Sutherland, invented by Cohen-Sutherland, which is popularly known as Cohen-Sutherland algorithm. Then there are several limitations of Cohen-Sutherland algorithm. So we subsequently would be talking about the midpoint subdivision algorithm, which overcomes the limitations and drawbacks of Cohen-Sutherland. And the third important agenda of this clipping chapter is Sutherland-Hodgman algorithm. So we'll be looking after these three algorithms in three different videos. So this part 1 video will focus on Cohen-Sutherland line clipping algorithm and some of the fundamental concepts. Okay, so what is clipping? If you try to define clipping formally, clipping is a process of extracting a portion of a database or identifying elements of a scene or picture inside or outside a specified region called the clipping region. So this is the formal definition of clipping. It is basically a process of extracting a portion of a database. You are extracting a portion of a database, not the entire database. You are only interested in some part or some specific part of a database, so you extract that. Or maybe you have a larger scene, let's say, and you are only interested in a specific region or maybe a picture inside that scene. So that much region we extract out, and this process of extracting the area of interest is called as clipping. Okay, here is an example. So there is a scene. We can see there are three windows shown in this diagram. Windowing one shows this is some object which is just like a mountain, let's say. So a scene is made up of a collection of objects specified in the world coordinates. So we have these as world coordinates, and this is some object that is shown here. Now the second window shows that we are only interested in some specific region that we define by means of a window. Like let's say when you look outside the window, the outside world is infinite, but when we apply a window to it, only some part of the window is visible to us. So when we display a scene, only those objects within a particular window are displayed to us. So this is the window which we also call it as a clipping region. And the third windowing 3, this shows that now out of this whole scene, only the portion which lies inside the window is extracted out. That is what we see in the third part. Because drawing things to a display takes time, we clip everything outside the window and we are only interested in the inside uh, part that lies inside the window or the clipping region. So this is the overall concept of clipping, that we take a scene and only a specific part of that is retained which is inside the window, and we wanted to do more studies on that part, or we are interested in that part, so we just take out that window portion. Now how do you do this? We can have point clipping, we can have line clipping, or we can even have advanced polygon clipping. So clipping, for the image below, we consider which lines and points should be kept and which ones should be clipped. So we can see that P4 is outside the window, and that this line segment is outside the window, and this should be discarded. Whereas P5, P6 should be retained, P1 point should be retained. There is some line segment here that should be retained, and this P9, some portion of the line segment that should be retained. So everything that is inside the window, which is defined by its y coordinates, wy min, wy max, and its x coordinates, wx min, wx max. These defined by these window boundaries should be retained. So the first among the three point clipping, line clipping and polygon clipping is, first among these is point clipping. It is easy. A point is not clipped if that point x, its x coordinate is greater than its the window's x min boundary, and it is less than the window's x max boundary. So a window is defined by the left boundary, that is x wx min, by means of its right boundary, that is wx max, then the top boundary, that is wi max, and the bottom boundary, that is wi min. So every clipping window has four boundaries, and a point is not clipped if its x coordinate is greater than wx min and it is less than ws max. So that means it lies somewhere in between the left and the right boundaries. So also we have to check its y coordinate. The y coordinate is greater than wi min, that is, this is wi min, and it is less than or equal to wi max. If it is so, that point is not clipped, it is inside the window, otherwise it is clipped. Like here we have several points in this, P1, P5, P9, these are the points within the window and these are not clipped, whereas point P2 is outside the window and it will be clipped. P4 is outside the window and it will be clipped. P7 is outside the window and it will be clipped. P16 is outside the window and it will be clipped. So this is point clipping. Okay. Now the next concept that would come out is the endpoint codes, or this is also called as region codes, which are actually been used in Sutherland-Cohen line clipping algorithm. So we had seen about the point clipping, how you clip the individual points. Now the next is line clipping. So for we know a line is specified by means of its two endpoints. So the codes for these endpoints are called as endpoint codes, or more popularly they are known as region codes, and these are 4-bit codes, 4-digit codes. So this technique uses a 4-bit code or 4-digit code to indicate which of the 9 regions contains the endpoint of a line, as we will see subsequently how we divide the whole of the space into 9 regions. This test is formalized by Dan Cohen and Ivan Sutherland. So it is also called as Cohen-Sutherland line clipping algorithm. It is something which is an extension of point clipping. The rightmost bit is the first bit, as we will see the convention how to remember in the subsequent part. The bits, it's a 4-digit or a 4-bit code. As we see, the bits are set to 1 based on the following scheme. The first bit is set if the end point is to the left of the window. So if the point is to the left of this window, then it is set to 1. The second bit is set if the end point is to the right of the window. So if it is to the towards the right of, this is the right window, and if the point is towards the right of the window, it is been set to 1. Then the third bit is set to 1 if the end point is below the window, so that means the bottom boundary, and if the point is below the window, like this P16 point, then its third bit is set. And the fourth bit is set if the point is above the window, so that is it is above this top boundary, it is above the window, like P4 point. So likewise we have these so-called as region codes. So Cohen-Sutherland line clipping algorithm based on region codes, that will be our next agenda. So this video focused only on the fundamental concept of clipping. We have 3 things to be clipped: point clipping, line clipping and polygon clipping, and we had seen the concept of point clipping, and for individual points how to find out the 4-digit 4-bit codes, which are 4-bit codes or 4-digit codes, which are also called as endpoint codes or region codes. Now in continuation with this, the next video will focus exclusively on Cohen-Sutherland line clipping algorithm based on the region codes. Thank you.